So another one of these messy fraction problems. Not terrible though, because when we look at the denominators, they're not too far off of each other. So our first step in any fraction problem is to examine the denominators. Why? Remember, I'm not recording your audio, but why are we looking at the denominators? Yeah, yeah. Now, even has a mathematical meaning, right? So what we actually want to say is they both need to be the same. So in this case, they will actually both be even, but we always just want to make common denominators is what we call that, right? So the 4 and the 2 are not common denominators. So since they're not common denominators, we start thinking about multiples. Now, one trick with fractions that we haven't talked about much yet is if you have a denominator that the smaller one can become the bigger one, that's all the work that you have to do. So we realize that 2 has a multiple that is 4, and then we determine how do we get there. So we ask, how do I turn 2 into 4? We multiply it by 2. But can I just do that on the bottom? No, we have to also do it on the top because we're keeping the value of the fraction the same while changing the numbers that represent it. So this now becomes negative 3/4 did not change, it stayed the same. This becomes 14/4, and always carry the denominator over. If you are making common denominators, we want to carry them over as soon as we can. So we go ahead and bring the 4 over, then we compare the numerators. So this is another like good guy, bad guy situation, right? So we got a bad guy 3 facing off against a good guy 14. Who's going to win here? Yeah, by how much? Yeah. So we're going to end up with 11 over 4. And if your answer wants you to reduce or put it into mixed number form, we can do that, but we can't reduce actually because 4 and 11 don't share any common factors that we could divide by. So we could say how many 4s are in 11? Well, 4, 8, 12. Nope, 12 is too much. So we've got 2 4s in 11 and then 3 left over. Cool? Makes sense?